Hi everyone. Today we will present our semi-supervised approach to training a deep convolutional GAN for roadmap and object detection. Our goal is to learn a mapping from the image space to the top-down space. The input consists of 6 images, forming a 360-degree view from a car's perspective, and the desired output is twofold: the roadmap layout and detected object. Since we are trying to find a mapping between the image space and the top-down space, it's similar to approximate the posterior, the probability of pixel being road given 6 input images, which we call a confidence map. We have adapted the idea from the paper mono layout. We constructed the generator with ResNet 18 as the only encoder to extract features from the 6 images, and 2 decoders with the same structure to build confidence maps for both tasks. Since we have much more unlabeled data in the dataset, we've also implemented 2 discriminators, which use the inputs generated from the unlabeled data as fake, rather than generating fake output from some random noise. The required output of the bounding boxes is an n×2×4 tensor of object coordinates. Since we need to fix the output of our network, we must transform our labels for training. For the labeled data, we use OpenCV2 to generate from the n×2×4 coordinates an 800×800 binary tensor, consisting of rectangular boxes representing the objects, as shown in Figure 4. We use OpenCV2 again to detect contours in the tensor generated by our trained network, and provide an n×2×4 output as the predicted object coordinates, as shown in Figure 5. We have trained our model in both supervised and semi-supervised ways. As you can see, in both cases, our models manage to generate pretty good roadmap approximation, but both struggle to achieve a good bounding box approximation. The improvement of semi-supervised learning in the bounding box model is significant, about 186%. However, for the roadmap approximation, we have only a 0.4% boost in performance. Here we have 2 scenes. Scene 111 comes from our training set, while scene 132 comes from the validation set. The roadmaps generated for scene 111 correlate well with the 360-degree view and have only minimal discrepancies from true roadmap. The roadmaps generated from scene 132 also provide a generally similar, albeit slightly fuzzier outline. The bounding box generation model is weak compared to the roadmap model. The main cause of this difference is the sparsity of bounding boxes. Because there are many more pixels that don't belong to any box than those that do, we have very imbalanced samples between the class of boxes and the class of other things, which adversely impacts our model.